Hi, today's lesson is to do with number properties. We begin with some basics of numbers. We introduce the natural numbers and move on to the signed integers, the positive and negative numbers that we well know. We then look at some of the familiar properties of numbers: addition, subtraction, division, and multiplication, the usual operations we study in school. Finally, we look at a very important function called the absolute value function. So let's begin by defining the natural numbers. The natural numbers are numbers that we learn in school, the counting numbers as they are called. We always begin counting with 0. 0, 1, 2, 3, 4, and so on. So this set is the set of natural numbers. Some textbooks begin the natural numbers with 1 onwards and some with 0 onwards. We will stick to the notation that natural numbers begin with 0 onwards. 0, of course, is a very natural number, and you do start counting with 0. So they are also called the counting numbers. We represent them on a number line moving to the right from 0, and these dots are the natural numbers. Let's see an example involving natural numbers. If a and b are two natural numbers and a by b is equal to 2.35, then a can equal which one of the following? So I'm given a divided by b is 2.35. The key here is that we are given that a and b are both natural numbers. So I get b is equal to a divided by 2.35. This puts some restrictions on a, because a divided by 2.35 is equal to b, and b must be a natural number. Natural number. So a can't be just anything. A has to be a special kind of natural number which, when divided by 2.35, gives me another natural number. So let's try all the options. 25 divided by 2.35 is not a natural number. 35 divided by 2.35 is also not a natural number. 47 divided by 2.35 is equal to 20. And 20 is a natural number. So we got our answer, C. A can be 47. If the number n equals 10 raised to 3 plus 2 times 10 raised to 2 plus 10 raised to 5, then the number of digits that are equal to 0 in the number n is. So firstly, this is some very strange way of depicting n. Let me write n the way we know it. So since they've given n in powers of 10 form, let me decipher what they mean. So n is just 1000 plus 200 plus 100,000. 10 raised to 5 is 1 followed by 5 zeros. So let me add these three numbers: 200, 1000 and 100,000 to get 101, 200, 101,200. Now it's easy. How many zeros are there in this number? There are 3 zeros. The answer is B. Moving on. Find the value of the 2-digit integer n equal to xy, where x and y are the digits of n. So n is a 2-digit integer. Say n is 37. So in this case, x is 3 and y is 7. So what's the value of the number n in terms of the digits? So n is 37 and we are given 3 and 7. How do I make 37 from 3 and 7? Well, this is just a question on place value. The number 37 is actually the number 30 plus 7, which is 3 times 10 plus 7. In terms of x and y, This is x times 10 plus y. So the value of the number n, when its digits are x and y, is 10 times x plus y, which is 10x plus y. And the answer is D. Let's move on to the next interesting set of numbers, the integers. So what are the integers? We know that the natural numbers, the set of natural numbers is 0, 1, 2 and so on. The set of integers, often denoted by Z, is the natural numbers and their negatives. So it's the set -3, -2, -1, 0, 1, 2 and so on in both directions. The negative numbers go on all the way down and the positive numbers go on all the way up. That is the set of integers. We denote it on a number line, as usual, moving to the right as the numbers increase and moving to the left as the numbers decrease. And all these numbers are the integers. In terms of the language of integers, the set of natural numbers would be the non-negative integers. The non-negative integers will include 0 and all the positive integers, and that would be the set of natural numbers. Let's look at an example. The sum of the positive integers from 1 through n can be calculated by the formula n into n plus 1 by 2. Which of the following equals the sum of all the even numbers from 0 through 60 inclusive? So what have they given? They've said the sum of the positive integers from 1 to n equals n into n plus 1 by 2. And what have they asked for? They've asked for the sum of all the even integers from 0 through 60. So that's 0 plus 2 plus 4 all the way to 60. That's the question. Can I directly substitute 60 for n? Surely not. If I substitute 60 for n, I'll get the sum of 1, 2, 3, 4, 5, 6 all the way to 60. I don't want that. I want the sum of only the even numbers from 0 to 60. I want 2, 4, 6, 8 all the way to 60. So how do I use this formula? Well, since they're all even numbers, they're all divisible by 2. So I can pull out 2 common as a factor. And I get 1 plus 2 plus 3 all the way to 30. Now I have the sum of integers from 1 to 30. So I can use the formula for this part. The formula for this part is just the formula given above with n equal to 30. So I plug it in. 30 into 30 plus 1 by 2. That's 30 into 31 by 2. And since I had a factor of 2 common, I multiply this by 2 to get 930. That's my answer, C. The important thing to note here was that the formula wasn't directly applicable. I had to factor out 2 common from all the even numbers, and then I got 1 plus 2 plus 3 till 30, and I could use my formula. Well, this is a very common and important formula. Let's look at some more such formulae. So we're going to look at the sums of squares and cubes of integers from 1 to n. We're not going to look at fourth powers, sorry. So what did we just look at? We looked at the sum of the positive integers from 1 through n. It's 1 plus 2 plus 3 all the way till n was n into n plus 1 by 2. We just saw an example of that. The next important formula is the sum of the squares of the positive integers from 1 through n. The sum of the squares, so let's write the squares. 1 square, 2 square, 3 square, all the way to n square. And then their sum, so let's put a plus sign between them. This is n plus 1, 2n plus 1 divided by 6. The third important formula is the sum of the cubes. So let's write the cubes. 1 cube, 2 cube, 3 cube, all the way to n cube, and add all these cubes. This works out to n plus 1 by 2 the whole square. Now this is interesting, related to the first formula. The first formula was the sum of the natural numbers from 1 to n, and that was n plus 1 by 2. This formula is the sum of the cubes of the first n natural numbers. So it's 1 cube plus 2 cube plus 3 cube all the way to n cube. And that is n plus 1 by 2 the whole square. It makes remembering simple. You just square the answer for 1 to n and you get the answer for 1 cubed to n cubed. The scoring system in a certain football competition goes as follows. 3 points for a victory, 1 point for a draw, and 0 points for a defeat. Each team plays 20 matches. If the team scored 9 points after 5 matches, what is the least number of the remaining matches it has to win to reach a 40-point mark by the end of the tournament? So there are 20 matches. It has already played 5 and it's got 9 points. So it has 15 left to play and it has to obtain 31 more points because it needs to reach 40 points in the next 15 matches. Well, that's not all. We want to do that in the least number of wins. So you want to get 31 points in 15 matches, but by winning the least number possible. The rest will of course be draws and losses. So we get 1 point for a draw and 3 points for a win. And we got to get 31 more points. So let's see how we get that. Let's just try the values. So suppose there were 6 wins. That means there were 9 draws. Will that do it? Well, 9 draws or losses. So if 6 wins would give me 18 points, plus 9 draws would give me 9 points. That's 27 points. That's not enough to reach 31. So let's try the next value. 7 wins. That would be 8 draws or losses. 7 wins would give me 21 points and 8 draws would give me 8 points. That's still just 29 points. Still not enough. Let's try 8 wins, which makes it 7 draws. 8 wins would give me 24 points, plus 7 draws would give me 7 points. That's 31 points, and we are done, because we need 31 more points. So the least number of wins is 8. The answer is C. Note that I used the answers and I started with the least answer because they want the least number. So starting with 10 would not help because that would it could still be possible to get a smaller number. Let's move on to another important function, the absolute value function. We learn it in school. It's often called modulus. Let's see what it means. So I look at any number on the number line, say 4, and I calculate its distance from 0. Well, obviously this distance is 4. I take another number, say minus 5, and I calculate its distance from 0. It's 5. And that's what the absolute value function does. It tells you the distance of any given number from 0. 4 has a distance of 4 from 0. So the absolute value denoted by these two parallel lines is 4. What about the absolute value of minus 5? Well, it's 5. We just saw that minus 5 is 5 units from 0. What about absolute value of 7.84? Well, it's 7.84 units from 0. What is the value of minus 0.042? It's 0.042 units from 0. So the absolute value of minus 0.042 is 0.042. So what's happening here? Well, what's happening here is if you give me a positive number, then its distance from 0 is itself. And if you give me a negative number, then its distance from 0 is its negative, because I need to make it positive. So if I take minus 5, I need to get 5. And the way to get 5 from minus 5 is to negate minus 5. Minus of minus 5 is 5. Let's enshrine this as a rule. So, given x, the absolute value of x is x if x is greater than or equal to 0. If x is 0 or positive, then the absolute value of x is itself. However, if x is negative, then the absolute value of x is not x, because x is negative. The absolute value of x is the negative of x. Because that's how I make a negative value positive, by negating it. So if x less than 0, then the absolute value of x is negative x. Here are some examples. 5 is 5 because 5 is greater than 0. Absolute value of minus 3 is minus of minus 3 because minus 3 is less than 0, which equals 3. Take your time, but you must understand this. This definition is all important. Let's see some examples. Will x be an integer satisfying the equation absolute value of 3 minus x equal to 7? Then which of the following can equal x? Well, they've given me values. I'll just plug them in and see what works. Let's try the first value. A equal to 5. That means x is taking the value 5. Absolute value of 3 minus 5. 3 minus 5 is minus 2. So absolute value of minus 2, which we know is 2. Is 2 equal to 7? No. So this is not the answer. Let's try B, 10. X is taking the value 10. 3 minus 10. That is absolute value of minus 7, which is 7. And we want it to equal 7 in the question. So here's our answer, B. Let x less than 0 be an integer satisfying the equation 2x plus 3 equal to 7. Then which of the following can be mod x? I'm underlying all the wonderful traps in this question. But let's see how many still get trapped. So I want to solve 2x plus 3 equal to 7. I try value A. So x is 2. 2 times 2 plus 3, absolute value is absolute value of 4 plus 3, 7, which is 7. Yes, we found our answer. So the answer is 2. Okay, let's go back to the question. Let x be less than 0. Is x less than 0? No, 2 is not less than 0. This can't be the answer. Let's try B, minus 2. So I put in minus 2 for x. 2 times minus 2 plus 3, which is modulus of minus 4 plus 3, which is absolute value of minus 1, which is 1, which is not equal to 7. So minus 2 is not working, even though it was a negative number. How about C, minus 5? I'll put in minus 5. 2 times minus 5 plus 3, which is minus 10 plus 3, which is absolute value of minus 7, which is 7. It's working. Is everything working? Fine. So I've got an answer. Minus 5 seems to satisfy the equation. Does it satisfy all the additional conditions? X less than 0. Yes, minus 5 is less than 0. So I've nailed my answer. The answer is C. Wrong again. Why? Because the question is not asking for x. Yes, x is minus 5, but read the question. Then which of the following can equal absolute value of x? So even though I got x equal to minus 5, the question is asking for absolute value of x, which is absolute value of minus 5, which is 5. And the answer is D. A really nasty question. They trip you up in many ways. What is the value, absolute value of x divided by x? Absolute value of x divided by x. Let's take different numbers and see what we get. So let me take a simple number like 3. So absolute value of 3 divided by 3 is 3 by 3, 1. Let's take a negative number because we know absolute value does things to negative numbers. So absolute value of minus 3 over minus 3. Let x equal minus 3. So I get absolute value of minus 3 over minus 3. But absolute value of minus 3 is 3. So I get 3 over minus 3, which is minus 1. Yep, so as expected, I got two different answers depending on whether x was positive or x was negative. So the answer choice is D. Is it? I've taken x as positive, I've taken x as negative. Does that cover everything x can be? No, x can be 0, which is neither positive nor negative. And what is modulus of 0 over 0? It's nothing. It isn't defined. It's not nothing as in 0, it's nothing as in does not exist. Absolute value of 0 divided by 0 does not exist. So the answer is E. Cannot be determined because we don't know whether x is 0 or not 0. If they had specified in the question that x was not equal to 0, then the answer would be D, 1 or minus 1. But here, they haven't said that. So we have to consider x equal to 0 also. And then everything breaks down because division by 0 is not allowed.